If a material has a critical angle in air of 34.4 degrees, what is the index of refraction of this material? We know that we can use Snell's Law and apply that to the concept of the critical angle. To find the index of refraction. To me, the tricky part of this, though, is trying to determine what is your n versus what is your n prime. Is the air going to be your n or your n prime? And so you just have to remember that critical angle is always referring to when light is going from the high index material to the low index material. And so the air must be the low index material, the second material, and so your n prime must be 1. So then we could say n times sine of the critical angle equals 1 times the sine of 90. And remember that the sine of 90 is actually also equal to 1. So the sine of theta c is equal to 1 over n. And we can plug in our 34.4 degrees to solve for n. And we come up with our index of refraction of the material is 1.77. And I'll just draw that out once more, because I feel like the critical angle is sometimes a tough concept. So here is the n of 1.77. This is our unknown material, and then the air with an index of refraction of 1. And if we draw in a normal, our angle, our critical angle for this material is 34.4 degrees, I should say for this interface, is 34.4 degrees. So maybe something like this. This angle is 34.4 degrees. So since that's a critical angle, that means that anything greater than that angle, any incident ray that comes in greater than the angle, will be reflected, not refracted, and would have total internal reflection. Also, at 34.4 degrees, a little bit of this light will still be refracted at a refracted angle of 90 degrees. And also, a lot of the light will actually be reflected, and you can use the law of reflection to know that the reflected angle is also 34.4 degrees.